Number 12, it's, we've certainly gone through a lot prior to number 12. And if you're struggling with the algorithm that Wells presents, you go back to the original problems, and we presented many, many examples of doing that. Here, what I'm doing, I'm resorting to software, and I'm going to reset like I always do. And maybe I shouldn't say always, but I try to. I'm going to find x to be a variable. And I'm going to say f of x is that function, which is x to the fourth power. It's a fourth degree polynomial. It's going to have 4 roots. Now, by the way, doesn't have to be real roots, but they're going to be 4 roots to the problem, minus 5. And what's interesting about this over here, it's really not a difficult problem to solve, but I'm gonna throw it at Sage, see what it does. Solve f of x. And let's type it in. Wow, look at that answer. And that's why people look at this and say, oh my God, I don't know what to do with that. Let me clear the screen though. It's really disturbing to see that. What I want to do is I want to plot it, P-L-O-T. And I get a visual understanding of what's happening over here. I think I just get the default plot, and I get that. Let me get rid of the old plot. We had an old plot up there. And I noticed that, maybe, let me display f of x, because that doesn't look right to me. x4, 2x cubed minus 5. You know what I'm going to do? I'm going to take my plot. I need to get, because I'm expecting to see something more looks like an upward cup. And let me see if I can do that now. And I'm going to do the plot again. And I'm going to change the x min. And I'm going to change that to minus 5. And this might be hunting and pecking. X max to be 5. And let's see what happens. Well, I'm getting a better picture. But you know what I noticed about this over here? I want to kind of trim down the y. Right? So I'm going to trim the y down now. So I'm going to do this over here. And I'm going to type in y min. I don't know. Let's make it minus 10. And let's like the y max. And they're easy to change. It isn't like I'm doing this by hand. All right, let me close out these prior pictures. I don't need them anymore. And I'm still gonna refine a little bit. All right, so I'm gonna change. Let's see. Let's go back over here. I'm gonna go minus 3 to 2. You notice how easy this is to work. And I'm going to say, I don't know, maybe minus 7. And I'm going to say 3 up here. All right? And you can do this all day long to make the curve as nice as you want it, or what you think is nice. What I'm noticing over here is I'm noticing there's only 2 real roots. All right? That means there's 2 complex roots. So what I'm going to do, clear the screen again. And I'm going to pull the picture down. And I'm going to try to match these roots over here for you. So I'm going to say find root of f of x. And I need to give it the interval. Now, the interval, I use integers. You can use other numbers. Like you can say, let's try things that are non-integer, like minus 2.7 and minus 2.2. All right? And let's hit return. What does it give me back this over here? The reason I want to do this over here, show you this doesn't have to be an integer. I've always been giving integer intervals, by the way. And let's do the next one, find root. And I can say it's between, I don't know, let's say 1.0. Let's put 1.01. Kind of crazy, right? And I'm going to say about 1.2, right? And hit return. What do we get? We get the second root. See how quick it does? Again, I do not know the algorithm that Sage is using, but I'm sure it's been, these numerical techniques have been long refined, and that's something about the code base of Sage. There's a lot of people working on it. I'm certainly not that skill set to work on a code base, by the way, but there's many people that are. And again, if you're interested in that, you can certainly look at their code for a find root. It's published. You can just look at it. All right? Thank you for paying attention, though.